In this video, we'll look at question 2 from the second paper of the 2017 exam. In this question, we have a rectangle PQRS in the Cartesian plane, and we know the coordinates of P and Q. They are 0, 6, and 1, 8. One other thing we know is that the point R is where the line perpendicular to PQ through PQ crosses the x-axis. So that kind of describes the position of R, although we don't know the coordinates. We'll have to work that out. And the easiest thing to do when we want to find the area of a rectangle is to know, or at least try and find, the lengths of its two sides. Then we can just multiply and we get the area. So to get the shorter side PQ, we can use Pythagorean theorem. We see that the difference in the x direction between the 2 points is just 1 squared plus this side, which is of length 2, that's 2 squared. And that gives us that the hypotenuse, the length of PQ, must be root 5. Now, in order to find the length of QR, let's try and find the equation of the line going through the points Q and R. And the key points of information which we want to answer before we find that is what is the y-intercept and what is the gradient. Can you find the answer to those questions? Well, the gradient of PQ is 2, because it goes up by 2 units in y on a distance of 1 unit in x. And if this line is to be perpendicular to it, it must have a gradient of 1 over times -1, and that makes it -1/2. The y-intercept is 8.5. And why is that? Well, as we just said from the definition of the gradient, 1/2 means that on a distance x equals 1, it will go up in y by 1/2. So even though it might not look like it on this picture because it's not to scale, the y-intercept is in fact 8.5. And that makes the equation of the line y equals, and now gradient times x plus y-intercept. That's the general form of a line in the Cartesian plane. We just substitute it into that. The point R lies on this line whose equation we have just found, but at the same time it's on the x-axis, which means when y equals 0. So let's combine the equation with y equals 0, and that gives us an equation in x, which is the x-coordinate of point R. And that can be solved to give us x equals 17. Okay, so this point is 17 here, which makes the length of this side 16, and this is trivially 8. Well, it's written here on the y-axis. And so we can use this right-angled triangle to calculate the length of QR using Pythagoras. So it's 8 squared plus 16 squared, and that's 8 root 5. Well, the square root of that is 8 root 5. This is just the Pythagorean theorem for the hypotenuse. Here's just a reminder of what PQ was. So that's the length of the other side. So the longest side is in fact 8 times longer than the shorter side. It's a very tall and narrow rectangle. And its area is, as promised in the beginning, just the product of the lengths of these two sides. And that's 8 root 5 times root 5. So the two roots combine to give us 5. 8 times 5 is 40. So the area of that rectangle is 40, well, units. We don't know what units they are, just 40. And in the exam, this option was E, and it was the correct answer to pick.